Sending this link in pretty much any Discord server lets you play Doom. You can use special commands such as this one to move forward, look around, and shoot bullets. To clarify, this public version only gives you access to the free shareware levels. It does not enable piracy of the full game. In this video, I'll show you how this works, how you can play it for yourself, and I'll talk about some of the technical challenges along the way. To find out how this is even possible, we first have to take a look at how Discord handles embedded content. When you send a link, Discord's backend first determines what server this link points to. Then, it sends a bunch of web requests to determine the type of content, along with relevant metadata, and then asks for the associated file. Meanwhile, the server looks at the link that Discord is requesting, finds the file associated with this link, and sends it over. Discord then renders everything into an embed, caches it, and displays it to the user. At least, that's how it's supposed to work. In reality, there's nothing stopping us from generating content, such as Doom gameplay, on the fly. Instead of using the link to find a pre-existing file, we can treat some part of that link as movement inputs for a game. The server can then record a video of that gameplay, convert it to a GIF, and send that back to Discord. To be clear, this is not hacking Discord in any way. It's technically a fully intentional feature of an HTTP server. I also don't get any of your personal information. I can only see Discord's IP address. This is all easier said than done, of course, but that's the big picture. For my first prototype, I used a speedrun-focused port of Doom called DSDA Doom. This is because it already has built-in support for recording gameplay to a video file, so I didn't need to do any extra work there. To handle player input, I could write some script that sends key presses to the game window, but there's a much more elegant solution. When you start up Doom for the first time, you might notice that there's a recording of gameplay in the background behind the menu, kind of like a demonstration of the game. Adequately, this system is actually called the demo system, and the files that hold the gameplay information are called demos. These are quite literally just sequences of inputs, taking advantage of the fact that Doom's engine is deterministic, meaning that the same exact inputs will always yield the same output. In our case, this means that we can generate a demo file based on the inputs in the link, and pass that directly to Doom without any additional scripts. Finally, the recording from DSDA Doom has to be converted to a GIF for embedding in Discord. Now, I could just output a video file, but that's not nearly as cool, and in most cases, Discord doesn't autoplay videos. With just these few components, I've already got a system that can generate Doom gameplay from a link. Admittedly, it's not very fast, and it's quite janky. You can even see the game window open up when the request is made, but that's why we call it a prototype. Before I can actually embed this into Discord, I have to put it on a server. Remember, Discord's backend has to communicate with a publicly accessible server to determine what content to display. It has no way to reach my locally hosted script. For the second prototype, I used a DOS emulator called DOSBox to emulate the original 1993 Doom. Once again, DOSBox already has a built-in video recording tool, so that simplifies things a bit. However, to enable video recording, you have to manually press a sequence of keys on the keyboard every time. There's just no other way to activate this feature. Luckily, DOSBox is open source, so I can grab the code and modify it to automatically call the recording function on a specific cycle. This is still super hacky, and because it's an emulator, it's also pretty slow, but for a prototype, I figured it would do. I just needed to put this whole thing on a server that Discord could access. Everything seems to work fine when opening the link in a browser, but once I try to embed it into Discord, I get back a still image. Taking a closer look, it seems that Discord has converted the GIF to a PNG during its rendering step. That's weird. I figured I might get some more answers if I looked into how other Discord GIFs work, but I just ended up with more questions. I have to give a shout out here to my friend Sony, who stayed up until late at night to debug this with me while we were meeting up at an event in Budapest. It turns out, Discord's embed system is a lot weirder than you'd think. When you send a cute cat GIF from a website like Tenor or Giphy, this is the link that Discord sees. That's not a link to a GIF for a video, but rather to the web page that the GIF was posted to. Curiously though, if you click on the Discord embed and then copy the link, it'll give you an address to the copy that Discord has cached, which in this case is an MP4 file? Yeah, so apparently when sending GIFs on Discord, half the time they're not even actual GIFs. They're just looped MP4 files pretending to be a GIF. But hold on, where does Discord even get an MP4 from? If you guessed that they converted the GIF to an MP4, you'd be excused for thinking so. That's not what's happening, but I wouldn't put it beyond them. You see, the webpage that hosts the original clip has some metadata tucked away in the HTML document. This is usually there to tell social media platforms how to properly embed the content. And, wouldn't you know it, one of these tags has a link to an MP4 file. One would think that simply mimicking the structure is sufficient for generating such an embed, and one would be wrong. Yeah, even if you outright copy all the code from the tenor page and serve that verbatim with the same HTTP headers and all, Discord still doesn't just embed the damn GIF, instead opting for a weird third option that still doesn't autoplay. At this point, I'm feeling pretty defeated, and I was getting very close to just giving up and generating an MP4 file without autoplay. That was until Sony suggested that I should try adding .gif to the end of the link. Yes, that's what got it to work. I bet some of you might be surprised that we didn't try this earlier, or that this wasn't immediately obvious to a couple of experienced programmers, but I think this is a classic example of just overthinking. See, the tenor links don't have a .gif extension at the end, or rather they don't have any extension at the end because, unlike files on a computer, that's not required for a web link. The HTTP spec instead uses the content type header to communicate the type of data it's sending, because heuristics like file extensions are less reliable. Being tech-savvy people, we know this stuff by heart, and we know better than to assume that just adding .gif to the end of a link will make it embed differently. But apparently, Discord absolutely doesn't care about the standard. Here's my best guess at how Discord's link embedding system works. First, before any requests are made, it takes a look at the link. If it recognizes the domain as one from a list of hard-coded GIF providers like Tenor, it uses strategy A. Otherwise, if the link has a file extension, it guesses the file type from that and uses strategy B. If all else fails, it falls back to strategy C. Now, both A and B eventually lead to some kind of a video being cached and embedded, while strategy C seems to turn any unlabeled animation or image, including a perfectly fine JPEG, into a PNG. This is horrible, and still really only the tip of the iceberg when it comes to Discord's backend jank. For example, I still can't explain why Discord has to send 4 identical synchronous GET requests to every link. Anyway, with that now resolved, I can finally embed Doom gameplay in Discord. Hooray, I guess. This still needs to be optimized, but before we do that, let's talk about input. At the start of the video, I mentioned that you can control the player with chat commands within Discord. What might surprise you is that this works anywhere and doesn't require a custom bot. See, Discord has a bunch of quirky hidden features, and one of those is text substitution through something that looks and quacks a lot like the Unix sed. Long story short, if you write s/some word/some other word, the first occurrence of that first word in your last message will get replaced with the second word. In our case, since the letter I appears only once at the end of this link, writing s/i/wi will prepend the letter W before that I, effectively adding an input to the sequence. But since this only affects your last message, sending something after the GIF will now make your commands point to that message instead. So look out for that. While it might seem that we're practically done here, there's still a lot that we haven't addressed. I don't think it's a surprise to anyone that this isn't something you're supposed to do with a web server. And Discord doesn't want to lend out its bandwidth for free either, so they impose a hard time limit of about 10 seconds per request. We tried working around this by trickle feeding data with an HTTP stream, effectively simulating a slow connection. But it seems that no matter how you do this, there's always a hard 10-second timeout. In our current implementation, that's a big problem. The DOSBox emulator runs Doom in real time, so any input sequence that takes 10 seconds to play will also take 10 seconds to record. This, along with many other logistical limitations, makes an uncapped playback unrealistic. One way to tackle this problem is to use save files. Let's say that my first input is to move forward. I perform this action and then save the game before closing it. If I now want to add something to that last input, I can simply load that save file and avoid re-recording the first action. Of course, this makes it so that the recording only ever captures the very last input, which isn't very exciting. But if we back up the save files on every step along the way, it becomes possible to start the sequence at any arbitrary point, like, for example, 5 inputs before the end of the demo. One small caveat with this is that Doom doesn't support playing back demos from save files, so I ended up writing my own demo playback system inside of DOSBox. With this, you can actually somewhat play Doom, though it still takes a really long time to respond, and it's absolutely not viable for use in production. If multiple people try to request a link at the same time, not only will the server become too congested to respond in 10 seconds, but the save files and videos will all get scrambled together because I haven't yet implemented asynchronous request handling. Basically, I need to make sure that there's never a situation where one process is reading some data while another process is trying to overwrite the same data. One such example comes from save files. If I'm starting one instance of Doom while another is saving its progress, there's a very good chance that something will break if both instances are using the same game files. I fixed this by using the -cd-rom launch option. This tells Doom to use a folder on the C drive to store game data. But because this is running in an emulator, the C drive can be whatever I want it to be. So I created separate folders for every input sequence in the cache to prevent any two different sequences from overlapping. And finally, we can run some benchmarks. Once this video comes out, I expect to see thousands of people trying this thing out at more or less the same time. My system has to be able to handle that initial impact, as otherwise I might be labeled a fraud when it ends up crashing for some of you. To alleviate some of the initial impact, I wrote a script that pre-caches all inputs up to depth 5, and another script that simulates a worst-case scenario given some parameters like player count and input depth. Starting off very small at 8 players, the system handles everything just fine. Doubling that up to 16 players, things immediately break down. The video files that this test generates don't even get to start Doom. The server gets so overwhelmed that even running DOS becomes a chore. And look, if it's gonna fail this badly at just 16 concurrent players, I have to really switch up my strategy. Okay, in hindsight, using DOSBox was a horrible idea. Emulation is computationally expensive, and there's really no excuse for emulating a game as portable as Doom. The only reason I had tried to stick with DOSBox was because I wanted to run an authentic version of Doom, but evidently that wasn't realistic. I ended up forking Chocolate Doom, which is basically an effort to maintain as much of vanilla Doom as is possible on modern systems. I could have chosen some other source port, but remember, this has to run headless without accelerated 3D graphics, and I just want to keep things as vanilla as possible. I implemented a feature for rendering video output, added the ability to start demos from save files, made RNG be deterministic across saves, disabled some transition effects, and a few more things here and there. Essentially, everything that I was previously handling with DOSBox and scripting, I was now doing inside of Doom itself. At this point, I was confident enough to let a few members of my Discord server try out this new project. Aside from being told that it's surprisingly fun, I was also pointed towards several cases where the demos would desync because of differences between save files. Say you've just walked past an enemy 5 inputs ago. Every new input up to this point has rendered a demo that starts from an earlier save file. And in most of these demos, you've successfully walked past that enemy. But on your 4th input after passing the imp, you load the save file and the enemy moves in a slightly different way than before, pushing you off of your path. you end up somewhere off to the side, even though you should have continued walking forward. This already looks confusing, but if you try to correct your position by, say, turning to the right, you'll actually load the 5th save file, which was created when you did successfully pass the enemy, so now you've effectively teleported, and these issues will only continue to pile up. A moment ago, I mentioned that I had made RNG deterministic across saves, and while that did help with making monster behavior more stable, I think this issue spans much further than RNG. Doom's save files aren't perfect. There are various little quirks that change how the game state is restored, and many of these can't be easily fixed. For example, monsters will actually forget that they're targeting you if you load a save file, which may in some cases change their behavior enough to desync the demo. To work around this, I decided to handle only one input at a time. This way you'd be making and loading a save file on every individual input, so there'd be no room for desynchronization. But as we've discussed before, the problem with this is that the output video shows only the last input, which makes it hard to get a sense of what's going on. Luckily though, the transitions between saving and loading are so seamless that I can actually stitch together individual clips of input sequences. This is made possible entirely thanks to the new recording pipeline. Speaking of which, because the video rendering is now a part of the Doom engine itself, I no longer have to limit the game to 35 ticks per second. For example, here's how long it takes to render a casual playthrough of Doom's first level. That was pretty much instant, but the video file it produced is orders of magnitude longer than what it took to make it. This means that, outside of video encoding, this whole thing is starting to look pretty cheap to run, at least from a computation standpoint. There's one more factor that I haven't yet mentioned, and it's honestly the one thing that scares me the most about the release of this project: storage space. Recording a sequence of inputs is obviously more computationally expensive than fetching a pre-recorded copy. It makes sense to keep around videos that have already been rendered and save files from paths that have already been played, so that you won't have to record it all again the next time someone uses those same inputs. But these files take up a ton of space. You might have already noticed that I've done away with GIFs in these folders, and throughout the video there have been appearances of a format called WebP. This is an animated image format similar to GIF, except with modern-day lossy compression. Where a 3-second Doom GIF could easily take up a megabyte, a WebP of the same length only needs a tenth of that. And, better yet, Discord labels both of them as GIFs, so they're effectively a drop-in replacement. Along with those WebP files, I'm also storing MP4s. This is because it's easier and faster to stitch together MP4 files without losing video quality. That brings our total cost per clip to about 180 kilobytes in the worst case scenario. This might not sound so bad, but with a playtime of 10 inputs from a set of 6 possible options, we would need about 12 terabytes of storage space to cache each possible sequence up to only 10 inputs. If you're concerned about Discord having to cache this, don't be. Their cache expires very quickly and is built to handle much bigger loads. For them, this is a drop in the water. For me, not so much. Since I don't plan on renting a giant storage cluster, I implemented a cache expiry system. While it's true that caching rendered files is efficient, you don't want to overdo it. Most sequences will only ever appear once, and there's no point in a cache that will never be used. But I also have to be careful to not delete caches of ongoing games, because new inputs depend on the data from previous inputs. One way to do this would be to set a hard time limit, for example, deleting sequences older than 30 minutes. This would work, but I'd have no way of knowing if it's optimal until I actually try it out in production, where it could easily turn out to be too aggressive, deleting ongoing games, or not aggressive enough, filling up disk space before the cache has a chance to be cleared. Instead, the current system just deletes the oldest file once disk usage reaches a certain threshold. This way, if it turns out I've massively overestimated the demand, the cache never has to be cleared. Or, if the demand rises to an unexpected level, the system would still be able to keep up. If you want to try this out for yourself, just type this link into Discord. Or if you're too lazy for that, I'll also leave the link below the subscribe button, which you should consider pressing. I'll continue doing more jank like this, sometimes Portal themed and sometimes not, but if this was interesting to you, I think you won't regret subscribing. Oh, and speaking of Portal, I did also make a version of this that runs Portal 2 in Discord. However, this one is not publicly available. Portal 2 is much more expensive to run compared to Doom. Hey, you might have noticed that this video got taken down and re-uploaded. Long story short, the last upload got hit with a false community guidelines violation, and YouTube rejected my appeal without giving me a reason. The thing is that only 13 minutes before that, someone tried and failed to DDoS the server that this project runs on, so I suspect it's the same sad and pathetic loser who mass reported the video. If you want to help me out in recovering the sunk costs and momentum, just sharing this video with your friends or Discord servers would help a lot. Thank you.